First and foremost was we did an extensive investigation of the standard x86 processors that are available in the market to ensure K6's functionality and compatibility with those processors. This was a very important task primarily because all the available documents are either vague or incomplete or just plain wrong. Then we developed a massive suite of directed tests which targeted all areas of functionality of K6. Then we developed a pseudo-random verification environment. Pseudo-random verification environment were primarily of two types. One, we targeted the memory subsystem, which was more like a module-level pseudo-random exercises, which generally verified the data cache, the instruction cache, the system bus, and the table walk unit. Then we developed what is called the pseudo-random instruction generator, which primarily generated all x86 instructions randomly, and we verified them against something we developed internally, which is called a software-based x86 processor instruction level. And after retirement of each x86 instruction, we compared the K6 versus this golden module. And if there is any mismatch with any registers, we flagged an error and stopped the simulation. Then we developed a memory model which had the capability of generating asynchronous events randomly, like interrupt, NMI, SMI, or stop clock, or even snoops. Then we extensively used assertion checks in our C++ model. Assertion checks was extremely useful in eliminating bugs which would not have been found otherwise, like in K6 is not supposed to do speculative table walks at any time. Assertion checks, we used assertion checks to make sure that we do not do speculative table walks under any circumstances. Then we used a static rule checker to eliminate all bugs in our ROM-based opcode sequencer. Last but not the least was we used extensively a hardware emulator, which was on which we booted all major x86 operating systems before we tapped out. So this is how we verified and our K6, and it was a pretty successful first step out.
I consider the emulation project to have been key to the success of K6. The thing about emulation is it gives you very high throughput, meaning high bandwidth for simulation in the order of hundreds of thousands of cycles per second. With this kind of capability, it's possible to run things that you could not do in simulation. This is certainly the first time that you get to do anything that is like a real-world application. The unique thing about the K6 emulation project is we managed to get this working quite a bit before tape-out. We were able to boot all of the available x86 operating systems and even run some industry-standard applications. This allowed us to find not only some of the obscure bugs in the processor, but to test some of the built-in engineering debug capabilities of the chip that could not be tested in simulation. One additional benefit of the emulation project was when we booted Windows. This was something that was never possible in a simulation environment, and it provided a huge morale lift for the entire project when that happened. And it provided the additional motivation and energy that was required to help the team through those last few difficult months prior to tape out of the chip.